Okay, as our final little thing on our weird exploration of polynomials, we're going to talk about division and then the fundamental theorem of algebra. So let's talk about dividing polynomials. So let's say that we have 3x to the fourth minus 5x cubed plus 4x minus 6, and we're going to divide that by x squared minus 3x plus 5. Okay, at its heart, dividing polynomials, there's a couple different ways we can do it. Much further down the line, you'll talk about actually factoring everything and cross-canceling. But if we're talking about something that are not factors of each other, then we really have a couple options. So think way back to, I don't know, 4th grade, 5th grade, when we did long division. So let's say we had 3,586 being divided by 23. If we wanted to do something like that by hand, we would have written 23 outside, have our 3, 5, 8, 6 inside, and we'd start going. We'd say, okay, does 23 go into 3? No. Does 23 go into 35? Yes, it does. It goes one time. And then we'd draw it and we'd subtract. And then we'd bring down the next number. Does 23 go into 128? Okay, yes, it does. How many times? And that is 5 times. So we put a 5, we'd say 5 times 23, which is 115. Again, we'd subtract and we'd bring it down. So we'd say, okay, does 23 go into 136? Yes, how many times? Well, 5 is 115. Couldn't quite get 6. Let's do 5 again. So that's 115, leaving us with 21 left over. We don't have anything more to go down. If we're doing it with decimals, we could put a decimal point, a bunch of zeros, and we could keep going. Alternatively, we could say that the remainder is 21. Yeah, so welcome back to elementary school. So a couple ways that we could write this. We could write it, our answer is 155 with a remainder of 21. We could have written it as 155 plus 21 23rds, if we wanted to think of it that way. We'd say 155, 21 23rds like this, and they all kind of meant the same thing. So when we divided 3,586 divided by 23, and we got our answer here, we did this long division process. Well, horribly enough for most people, we're going to do the same thing with letters. So if we are dividing this big thing by this goes inside our little roots. I'm going to do the same thing. Now, it is important that we include placeholders. So notice that we're missing a 0x, or missing an x squared. So I'm actually going to write a 0x squared in here. So I've written it out. And we're dividing by x squared minus 3x plus 5. So what we're going to do is we look at the lead number. So we're going to say, does x squared go into x to the fourth? Yes, it does. And it goes in 3x squared times. What we're trying to do is we're going to multiply it by whatever will exactly match it. So 3x squared times x squared is 3x to the fourth. And now I multiply it to each of these. 3x squared times negative 3x is minus 9x cubed. 3x squared times 5 is plus 15x squared. Now, when we did this over here, we then subtracted, and we're going to have to do that exact same thing. We used to use a little mnemonic, draw the line, reverse the sign. So we're going to draw the line, and now we're going to subtract. So 3x to the fourth minus 3x to the fourth cancels. Negative 5x cubed plus 9x cubed is 4x cubed. 0 minus 15x squared is minus 15x squared, and then I can bring down the rest. So now I do it again. We have a 4x cubed. Does x squared go into it? Yes. How many times? 4x times, because 4x times x squared is 4x cubed. I now multiply that 4x times each of them. So 4x times minus 3x is minus 12x squared. 4x times 5 is plus 20x. I draw the line, and we are subtracting. 4x cubed cancels with 4x cubed. Minus 15 plus 12 is a negative 3x squared. 4 minus 20 is negative 16x. And then minus our 6. Okay, finally, x squared. Does x squared go into negative 3x squared? Yes, it does. Minus 3 times. So negative 3 times x squared is negative 3x squared. Negative 3 times negative 3x is plus 9x. Negative 3 times 5 is minus 15. Again, draw the line, reverse the sign. We're subtracting. Negative 3x squared plus 3x squared cancels. Negative 16 minus 9 is negative 25x. Negative 6 plus 15 is plus 9. That would be my remainder. So my answer is this thing up here with this is the remainder. So I'd have 3x squared plus 4x minus 3 plus, and we're going to write it as a fraction. So just like here, it was what was left over divided by what we are dividing by. Here, it's what is left over what we are dividing by. This is polynomial long division. So I'm going to do a couple of them just so we can see examples of it. All right, let's try x cubed plus 5x squared minus 7x plus 2 being divided by x minus 2. Okay, so I can write it out. So I'd put my bracket on. We have x minus 2 on the outside. Get rid of this guy for the moment. And now I can start going. There's no missing spots. I don't need any placeholders. So x goes into x cubed, x squared times. So that gives me an x cubed minus 2x squared. Draw the line and subtract. They cancel, which is what we want every single time. 5 plus 2 is 7x squared. And I bring everything down. Okay, x going into 7x squared, yes, it goes in 7x times. 7x times x is 7x squared minus 14x. Draw the line, reverse the sign. These cancel, negative 7 plus 14x is 7x plus 2. X going to 7x, yes, goes in 7 times. 7 times x is 7x. 7 times negative 2 is minus 14. Draw the line, reverse the sign. 7x minus 7 cancels. 2 minus negative 14 is 16. So we'd have a remainder of 16. So my answer is x squared plus 7x plus 7 plus 16 over x minus 2. All right, let's do one more of these, and we'll talk about our next type. Okay, let's do 2x to the 4th plus x cubed plus x minus 1 divided by x squared plus 2x minus 1. Okay, so we're going to write it out. 2x to the 4th plus x cubed. We're missing an x squared plus x minus 1. Write in our little sign. Or dividing by x squared plus 2x minus 1. So x squared goes into x fourth. 2x to the 4th, yes. It goes into x squared times. 2x squared times x squared is 2x to the 4th. There's our check. We did it right. 2x squared times 2x is plus 4x cubed. 2x squared times negative 1 is minus 2x squared. Draw our line. Reverse the sign. We're subtracting. Cancels. 1x cubed minus 4x cubed is negative 3x cubed. 0 plus 2x squared is plus 2x squared. And then I bring down the rest. Okay, x squared goes into negative 3x cubed. Yes, goes in negative 3x times. Again, I'm always multiplying by whatever would exactly match that lead term. Negative 3x times x squared is negative 3x cubed. Negative 3x times 2x is negative 6x squared. Negative 3x times negative 1 is plus 3x. Draw the line, reverse the sign, we're subtracting. These cancel. 2 plus 6 is 8x squared. 1 minus 3 is minus 2x. And we bring down our minus 1. X squared goes into 8x squared. 8 times. So 8 times x squared is 8x squared. 8 times 2x is plus 16x. 8 times negative 1 is negative 8. Draw the line and reverse the sign. Let's subtract. These cancel. Negative 2 minus 16 is negative 18x. Negative 1 plus 8 is plus 7. There's my remainder. So my answer is 2x squared minus 3x plus 8 plus negative 18x plus 7 over x squared plus 2x minus 1. Polynomial long division. Now, if we have simple factors, there's an easier way we can do this where we're not going to use up so much paper. And that's called synthetic division. So the remainder theorem basically states that if we divide something, it comes out nice and even. If the remainder is 0, then that means it was a factor. So let's take a look at what we can do with the synthetic division instead. This is why we were practicing synthetic evaluation in that earlier lesson. So let's say we had that, 2x cubed plus x squared minus 8x plus 5. And we're going to divide it by x plus 3. Well, if we were to do this, so using synthetic division, what I can basically do is I can take the factor from this guy. So if we had x plus 3 equals 0, that means x would be equal to negative 3. So I'm going to use negative 3 in our synthetic division thing that we did before. So I take my negative 3 out here, and now I'm going to write down the coefficients just like we did before. 2, 1, negative 8, and 5. Now we can do our synthetic evaluation process. So I bring down the 2. 3 times negative 2 is negative 6. Gives me a negative 5. 3 times negative 5 is 15. That gives me a 7. 3 times negative 7 is negative 21, which gives me a 16. So how is this useful, you say? Well, because we're basically dividing it, this is giving us the coefficients to an answer. So originally, this was our x cubed, our x squared, our x, and our number. By the time we get down here, we've reduced that by one factor. So this is x squared, x, number, and this is now our remainder. So dividing this actually yields 2x squared minus 5x plus 7 plus 16 over x plus 3. So this is a much more compact way of doing things. The biggest limiter of it is we can only use it for nice, pretty little things that we can divide by. We can't do this with more complicated polynomial division. But if it's a single factor term like that, we can actually use synthetic division instead. So let's try it again. Let's say we were doing x cubed plus 4x squared minus x minus 1 being divided by x plus 3. Okay, so looking at this factor, that means x would have been equal to negative 3. So I'm going to put negative 3 outside, and I write my coefficients. It's a 1x cubed, 4x squared, a negative 1x, and a negative 1. Bring down my first number. Negative 1 times 3 is negative 3. 4 plus negative 3 is 1. Negative 3 times 1 is negative 3. Negative 1 plus negative 3 is negative 4. Negative 3 times negative 4 is 12. 12 plus negative 1 is 11. So now we can match it. So we started with x cubed. So now this is going to be an x squared, an x, a number, and our remainder. So my answer is 1x squared plus x minus 4 plus 11 over x plus 3. So with simple cases like this, synthetic division is much more compact. It's a lot easier to do. All right, so now let's actually use this a little bit. So last lesson we were talking about factoring things. So let's say we have some horrible polynomial, 3x cubed minus 4x squared minus 28x minus 16. And they tell us to factor it. We go, okay, well, maybe we can make, it's 4 terms, so maybe we can somehow make factoring by grouping work, but we tried out, it doesn't work. So what do we got? Some options. Well, it turns out if we know what a factor is, then we can use synthetic division to reduce this down to something we can actually work with. So let's say that we know that x plus 2 is a factor. If I somehow know that x plus 2 works, and we'll talk about how we'll actually figure that out later, then I know that if I divide by -2, then there should be no remainder. There's nothing left. It actually went in clean. Nothing was left over. So I'm going to use this -2 now in synthetic division. So that's a 3x cubed minus 4x squared minus 28 minus 16. And we'll know we're right if it comes out as 0 at the end. So I bring down my 3. -2 times 3 is -6. -4 plus -6 is -10. -2 times -10 is 20. -28 plus 20 is -8. -2 times -8 is positive 16. -16 and 16 is 0. And there's our proof that it was actually a factor. So this is what we're talking about, the remainder theorem. So if we use this as a factor and we divide it through, we should, in theory, get no remainder. There's nothing left over. It actually went in nice and perfect. So now if I go to factor this big ugly thing, I now know that x plus 2 was part of it, and what would be left is 3x squared minus 10x minus 8. This we can now try to factor. Maybe we can't factor it, maybe we can, but we can actually try. So here's 3 and 1. 8's going to be an 8 and a 1 or a 2 and a 4. And we need some combination to give us a 10. So 12 and 2 would work. So 1 going to the 2, 3 going to the 4. We need to be a -12, so that'd be a -4, and a positive 2. So that's x plus 2 times 3x and x. The 3 is going to the 4, so it'd be x minus 4. The 1 is going to the 2, plus 2. Now we've managed to factor something that we couldn't factor before, just because we knew one of the things that we're going into. Okay, so let's do that process again. So let's say we want to factor x cubed minus 6x squared plus 5x plus 12, and we know that x minus 4 is a factor. So if I know x minus 4 is a factor, that means 4 should go into this. Nice and neat. So I'm going to set up my synthetic division again. 1, -6, 5, and 12. And I have a 4 on the outside. I can bring this down. 4 times 1 is 4. -6 plus 4 is -2. Gives me a -8. 5 plus -8 is -3. Gives me a -12, and there's my 0. So it worked. Check. So factoring this now gives x minus 4 times, and what we'd have left over is x squared minus 2x minus 3. This is now a quadratic that we can now factor. So that gives me x minus 4. We're going to have an x and an x. So this would have to be factors of 3. That gives -2, so it would be a -3 and a +1. And we factored that thing. Even though looking at the original, we can't see a way to do it. So that's how we use synthetic division to actually factor. So we've talked about 2 different ways to actually factor things. Now let's go to something so important, it's called the fundamental theorem of algebra. And I think I'm running out of paper. Shift over some graph paper here for the end. fundamental theorem of algebra states a couple things. The big one that it states is that when we're working with a polynomial, the degree, so remember n is the degree, that tells you how many solutions there are to that polynomial if we set it equal to 0. So if I set the polynomial equal to 0, there are going to be n answers. Now, what you need to keep in mind here is that they're not n real answers. There are n answers in the complex. So it could be real, it could be i's, it could be roots, it could be anything. It's just if we include complex values, there are that many answers. All right. I am kind of shortening this down a little bit for the sake of the video. In class, I'll go over the fundamental theorem in a little more depth, but this is basically what we're going to pull away from, is that for a polynomial, if we set equal to 0, the n tells us exactly how many solutions there are total. So what could we do with this? Well, let's do a nice big horrific example, something horrible. So let's say we had x to the 5th minus 4x to the 4th plus 4x cubed plus 10x squared minus 13x minus 14. And we wanted to actually find all the zeros. We want to know when that's equal to 0. Okay, this sucks. There's a whole bunch of topics that we're not going to talk about, like Descartes' rule of signs, that tell us numbers we can guess and check. Instead, we're going to cheat. So first thing I'm going to do is I'm going to take that big horrible thing and I'm going to stick it into a calculator, stick it on Desmos, something. So let's actually stick it into Desmos and take a look. Let's go into Desmos. You can do it on your graphing calculator, whatever we want to do. All right, so let's stop sharing this real quick. And let's take a look at Desmos here. So when we go to Desmos, I'm going to go ahead and type out that horrible thing. So we had x to the 5th there it goes. Minus 4x to the 4th plus 4x cubed. Oops. See, this is getting uglier and uglier. Plus 10x squared minus 13x minus 14. Okay, so we've got it all in. So this weird thing looks something like that. So our key here is we're going to talk about multiplicity of roots real quick. When I look at a root and the graph is actually passing through it, the number of times that that can be a solution has to be an odd number. So x equals 2 is nice and neat and it's perfect on our graph. So we know a factor is x minus 2. We know that's a factor. Maybe it shows up once, maybe it shows up 3 times, maybe it shows up 5 times. But I at least know that x minus 2 is a factor. If a graph comes up and touches, just barely touching it, that means it has to have happened an even number of times. So x minus 1 here, or x equals -1 is the solution. That means that x plus 1 has to be a factor at least twice. So it's going to show up at least 2 times. So we're going to use these facts, and we're going to use what we see when we look at a graphing calculator Desmos to know what to do with this giant ugly polynomial. So looking at our graph, we knew that x equals 2 was an answer and that x equals -1 happened at least twice. So we can actually use this to try to fix things. What I'm going to do is I'm going to take this big, ugly, massive thing, and I'm going to use synthetic division using these factors to actually break this down more and more. So we have 1x to the 5th minus 4x to the 4th plus 4x cubed plus 10x squared minus 13x minus 14. All right, I know 2 should work. We looked at it on the graph. We saw it was a 0, so 2 should function as an answer. So now I'm going to do synthetic division and see what we get. So that's 1. 2 times 1 is 2. Negative 2. Negative 4, 0. 0, 10, 20, 7, 14, 0. Perfect. No remainder. It worked. That's what we saw on the graph. So that, after using that factor of our answer of x minus 2, we now have, again, dropping down each time, x to the 4th minus 2x cubed plus 0x squared plus 10x plus 7. Now we're going to do it again. We have 2 more. We know that negative 1 shows up at least twice. So I can do this process 2 more times using negative 1. So that's 1, negative 2, 0, 10, and 7. And I'm going to use negative 1 this time. So that's 1. 1 times negative 1 is negative 1. Negative 3, 3, oops, 3. Negative 1 times 3 is negative 3. Gives me 7. Negative 7, 0. Perfect. It worked again. At this point now, we'd be down to x cubed minus 3x squared plus 3x plus 7. All right, this is looking a lot better. We know another real solution. Which is another negative 1. So I'm going to do negative 1 in there again. So that's negative 1, that's 1, negative 3, 3, and 7. 1 times negative 1 is negative 1. Drop down the 1. 1 times negative 1 is negative 1. Negative 4. 4, 1, wait, 7. You can tell I'm tired, I'm starting to add wrong. Negative 1 times 7 is negative 7. 0, it worked. Now we're all the way down to x squared minus 4x plus 7. Almost there. You can tell I'm not going to give you very many of these. They take a while. So now that we know that this whole thing can be factored into x minus 2, x plus 1, and then x squared minus 4x plus 7, we can now solve these to find all of our answers. So we know 2 is an answer. We know negative 1 is an answer that shows up twice. But the fundamental theorem of algebra says that we should get 5 answers. We still need to take this guy right here, our x squared minus 4x plus 7, and set it equal to 0. Now, if it were real answers, we would have seen it on the graph. Problem is, we only saw those 3 things kind of on the graph. That means this guy's probably going to be complex. So we look at it, can't factor it, it's time for the quadratic formula. So x is equal to negative b plus or minus the square root b squared minus 4 times a times c all over 2a. So that's 4 plus or minus 16 minus 28 over 2. I'm running out of room here. So that's 4 plus or minus the square root of negative 12 over 2. Square root of negative 12 we can reduce. That's 2i root 3. So that's 4 plus or minus 2i root 3 over 2. 2 goes in both of them. And we get 2 plus or minus I root 3. There's my other 2 answers. So my 5 answers are 2, negative 1, and 2 plus or minus I root 3. So from the top, if we just have a giant ugly thing like this, which is worst case scenario, normally I'm going to give you ones that work out a lot quicker and easier than this. First step, we're going to put into a calculator, put it in Desmos, and actually see what some of the real answers are. It's not going to show us all of them, though. It's only going to give us some of them. We're then going to use those actual answers in synthetic division to reduce that fifth order as much as possible, hopefully all the way down to just a quadratic. Maybe it can go all the way down. Maybe we can actually break up the whole thing right off the graph. But we need to break it down as much as possible. Here we got down to a quadratic, and then we used the quadratic formula to actually solve it. So this is the last step of what you're going to do with the division here on this. I'm going to give you formulas, usually not this ugly. You're going to plug it into a calculator at Desmos, see what actual solution works, write them down, and then use those in synthetic division to break it down.